Hello students, I will be discussing 24th January morning physics paper. So let us start with the first question. This question is from thermodynamics. So let me read the question. It says an ideal gas goes from initial state to final state. During this process the pressure of the gas increases linearly with temperature. So what is mentioned is that pressure is directly proportional to temperature. If I have to plot the graph, pressure versus temperature graph is linear. It clearly is an isochoric process. And we know in isochoric process work done by gas is zero, because work done by gas, that is PdV, integration PdV. So there is no change in volume, and when there is no change in volume, work done by the gas will be zero. So statement 1 is correct. Then we have second statement, the heat added to gas is different from change in its internal energy. Well, that's not correct as per the first law of thermodynamics. If I write the equation of first law of thermodynamics, it says Q is equivalent to delta U plus work done by gas. So we've already seen that work done by gas in isochoric process is zero. So Q and delta U, they are same. So statement B is not correct. Then let me read the third statement. The volume of the gas is increased. Well, as I said that the process is isochoric, so volume has to stay constant. Internal energy of the gas increases. Well, that's correct, because you can see from the graph itself that with increase in pressure, temperature increases. And if temperature increases, internal energy does increase. NCV delta T is positive, so internal energy increases. Had the pressure been reducing, temperature would have reduced, internal energy would have decreased. The process is isochoric. Well, that's true. So this statement is also correct, and this statement is also correct. So let us shift to the next question, but before that let me mark the correct option. The correct option is ADE, right? So let's go to the next question. Now this question is from wave optics, from a very famous topic, YDSC. Let me read to you the question. The question says, a Young's double slit experiment is performed with bichromatic light. So we have two wavelengths in our incident light. The wavelengths are 480 nanometer and 600 nanometer. The least number of bright fringes of 480 nanometer light that are required for first coincidence with the bright fringes formed by 600 nanometer light is. So let me give you a little bit of background. This is a screen. These are our two slits. The distance between the slit and the screen, in the standard theory we keep that as D, capital D. The distance between the two slits is small d. This is our incident light. Wavelength of the incident light, say for example, is lambda. This distance is small d. On the screen, if we want to know the location of the bright fringes, we know there is a very famous result which I would obviously not be deriving here, that if we want to know at point P on the screen, is it a bright fringe or a dark fringe, the condition is for bright fringes y is equivalent to n lambda capital D by small d. This will give us the location of the bright fringes on the screen. I mean, you can see that the location of the bright fringes depends upon the wavelength of the light used, and also it depends upon capital D and small d. Well, in this case, for the two light wavelengths, capital D and small d is same. The question wants that the bright fringe of lambda 1 and the bright fringe of lambda 2, they should coincide. Coincide means y, their y coordinate needs to be same, which basically will happen when n1 lambda 1 will be equal to n2 lambda 2, right? So which basically means n1 by n2 is equivalent to lambda 2. Well, lambda 2 is 600 divided by 480, right? So we have 412. So this basically is 5 by 4. So it is the fifth bright fringe of 480 nanometer, which is coinciding with the fourth bright fringe of 600 nanometer. Similarly, 10th bright fringe of 480 nanometer is going to coincide with the 8th bright fringe of 600 nanometer. Anyways, the question was, where will first coincidence happen? Well, first coincidence will take place when the fifth bright fringe of 480 nanometers, that's going to coincide with the fourth bright fringe of 600 nanometer. So the answer of this question is 5. Let me shift to the next question. Well, this question is from the topic electric potential and capacitance. A very simple question. It basically says that we have a parallel plate capacitor. We know that if we have a charged parallel plate capacitor, the electric field between the plates of the capacitor is epsilon naught by, actually sigma by epsilon naught. Near the edges there is little bit of fringing, which we don't have to consider in this question. We also know that electric field stores energy, and in the unit volume, the energy stored per unit volume is half epsilon naught E square. Anyways, here E is given, electric field between the plates of the capacitor. He's asking us to find the total energy stored within the plates of the capacitor, or between the plates of the capacitor, in the electric field that's present between the plates of the capacitor. Well, if we know energy stored in unit volume, and because we have to ignore fringing effects, so everywhere electric field is same, so in every unit volume energy would be same. And in that case, the total energy stored between the two plates can very easily be found by multiplying energy density with the volume, the volume of the space where electric field is present. The volume of the space where electric field is present is A into D. You can see the D is gap between the two plates, A is the area of the plate. So the answer of this question happens to be half epsilon naught E square into AD. So let us shift to the next question. Now, this question is from optics, ray optics to be precise, and this question happens to be from a subtopic, silvering of lenses. Let me read the question. A thin plano-convex lens made of glass of refractive index 1.5 is immersed in a liquid of refractive index 1.2. So there is a plano-convex lens. Let me draw a plano-convex lens. The refractive index of the lens is 1.5 and surrounding medium's refractive index is 1.2. When the plane side of the lens is silvered, so the plane side it is silvered. It's not the concave side, it's the plane side which is silvered. So this I'm going to quote, this is the axis of the silvered lens. The lens immersed in the liquid behaves like a concave mirror of focal length 0.2 meters. Well, we teach this in standard theory that any silvered lens can be treated as a mirror. Effectively, it can be treated as a mirror. The focal length of that mirror we calculate from this formula. So in this formula, F equivalent is the focal length of that effective mirror, which in this question has been given as 0.2. To be precise, minus 0.2, because the question is saying that this entire system is behaving as a concave mirror. So in concave mirror, as per the sign convention rules, focal length is negative, right? Focus is somewhere here. The distance is measured from pole to the focus, so it's opposite to the direction of the incidence. So that focal length F equivalent is given as minus 0.2. 1 by FL we are going to find from lens maker's formula, focal length of the lens, which is refractive index of the lens material divided by refractive index of the surrounding medium minus 1 into 1 by R1 minus 1 by R2, where R1 and R2 are the radius of curvature of the two surfaces. Here I believe we have to find R1 and R2 is infinity, the other surface is plane. And Fm is the focal length of the silvered part of this part which is silvered, which is basically infinity. It's a plane surface. The radius of curvature of the plane surface is infinity, and focal length of the mirror is radius of curvature divided by 2. So this term basically in this question is 0, isn't it? So let me plug in the values and I think we should have the answer. So it is given as minus 1 divided by, as I told you, F equivalent is minus 0.2. That's where many students can make the mistake. This is equal to 2 into, so for refractive index of the lens is 1.5, refractive index of the surrounding medium is 1.2, minus 1 into 1 by R. That's what we have to find. R is the radius of curvature of this. That we have to take positive as per the sign convention rules, because R is the distance from the pole to the center of curvature of this spherical surface, We are measuring it in the direction of incidence, so r is positive, and as I told you, the other surface is flat and its radius of curvature will be infinity. And about 1 by fm I have already told you. So minus and minus will cancel out, and we will have 10 by 2, which is 5, is equivalent to 2 into, this will be 5 by 4 minus 1 into 1 by r. So this further reduces to 5 is equivalent to 2 into 1 by 4 into 1 by r. So we basically have r equal to 2 divided by 20, which is 1 by 10, which is 0.1. So the answer of this question should be 2. Overall, this question, to be able to do this question, you should be aware of lens maker's formula. You should be aware of the fact that silvered lenses can be treated as mirror, and the focal length of that mirror is given by this formula, which is derived in any standard textbook. Let us shift to the next question. Now this question is from work power energy, a very basic question, basically just based on the definition of work. What is work? So there is a force which is acting on the object. It is acting in x direction, so it's going to displace the object in x direction. We are given the total work done. I believe we have to find the value of beta. So we know the definition of the work is integration f dot dx if the force is variable, as it is here. The force does depend upon x. It increases as the particle goes on. So to find work done, already given, that's 5 joules. So force is given as alpha plus beta x square, right, into dx. And the angle between the displacement and the force is 0, because force and displacement are in the same direction. So that cos theta term becomes cos 1. Sorry, cos theta becomes cos 0, which is 1. And we have to integrate it from, the object is displaced by 1 meter, so it's starting from origin, I believe, and uh, it's having a displacement of 1 meter. So this becomes 5 is equivalent to alpha x plus beta x cube by 3. So I think they've given the value of alpha as 1, so it is 5, and okay, we have to put the limits also, 0 to 1. So alpha is given as 1, so we have x plus beta x cube by 3. Now I'm going to just substitute the limits and we should have the answer. So 5 is equivalent to, first I'm going to substitute upper limit. Now once you substitute lower limit, it is going to be anyway 0. So 5 minus 1 is 4, 4 into 3 is 12. The answer of this question is 12 Newton per meter square. A very basic question based on the definition of work done. Let's go to the next question. This question is from simple harmonic motion, kinematics of simple harmonic motion. A very simple question again. Let me just explain to you the background of this question. So we know in simple harmonic motion, we have a particle which goes to and fro periodically about the mean position. So I'm marking this as the mean position, and these are the extreme position. Simple harmonic motion is a bound motion, right? The distance from mean to extreme, well, that's called as amplitude. The time taken for one oscillation is defined as the time it will take to come back to the, this is the time, this is one oscillation. The time it takes to complete one oscillation will be called as time period. Time period of this motion is 2 seconds. In one oscillation, as you can see very clearly from the diagram, the distance covered is 4a, mean to extreme, extreme to mean, mean to left extreme, and left extreme to the mean. So in one oscillation, the total distance covered is 4a. And in 12.5, you can see we can break this 12.5 number, 12 seconds plus half a second. In 12 seconds, because the time period is 2 seconds, we can have 6 complete oscillations. And in one oscillation, the distance that it covers is 4a, and in 6 oscillations it will cover a total distance of 24a. And in half a second, it will be able to complete only a distance of a, because in half a second basically here is t by 4. And in t by 4, the distance covered by the particle in SHM is from, it goes from mean to extreme, or extreme to mean, or mean to left extreme. That distance is a. So total distance covered by this particle is 25a, right? So suppose the particle started here at t equal to 0. At t equal to 2 seconds, it will be here, then again at 4 it will be here, then again at 6, then again at 8, then at 10, then at 12. When at t equal to 12, it will be here, and after another half a second, it will be at the right extreme. It will be here at t equivalent to 12.5 seconds. So look at the displacement. What is displacement? Displacement is the length of the straight line joining the initial and the final point. So our initial point is here and our final point is here. The distance is a, the magnitude of displacement is a. So displacement, distance is 25a, displacement is a, and we have to find the ratio. So you can very clearly see the answer of this question is 25. That's option A. Let's go to the next question. Now this question is from semiconductor devices. It is a theoretical question. We need to carefully check each and every option. We need to be smart while choosing the answer here. So let me explain each option carefully. The junction area of the solar cell is made very narrow compared to the photodiode. If you see in this question, they're talking about three devices: solar cell, LED, and photodiode. So we should have first some idea of LED. What is LED? Light emitting diode. What is the principle of how LED works? So basically we have LEDs are made of very special material like gallium arsenide phosphide. Anyways, in any unbiased PN junction diode, we have N side which is positive. Near the junction there is a immobile positive layer, and similarly on the P side there is this negative layer, and there is this electric field in this region. This region is known as depletion region. As every one of you know, there are excess electrons. These electrons are free. Their energy corresponds to what we know as conduction band. I'll draw that energy diagram. So on this y-axis I'm plotting energy. We know that electrons which are present in conduction band, meaning electrons which are free, their energy is more compared to those electrons which are bound. Their energy corresponds to what we know as valence band. So in case the electron has to go from valence band to conduction band, we need to supply energy equal to the band gap. Or in case electron has to de-excite from higher energy level, which is the conduction band, to valence band, in that process it will emit light, and that's what exactly happens in LED. So in LED what we do is that when it is unbiased, obviously electrons cannot diffuse through. This electric field, this local electric field present near the depletion region prevents electrons to go to the P side, or for that matter holes or valence electrons to the P side. So what we do is that we do external biasing. We connect P side to higher potential and N side to lower potential. Now this kind of biasing, what it does is that it attracts the electrons and they penetrate, they pass through, they punch through the depletion region, and some of them get trapped, or many of them get trapped in these vacant orbitals that are present on the P side. These holes is nothing but a presence of vacant orbitals. And in that process, electron basically de-excites from conduction band to the valence band. And whenever electron de-excites, we have photons released, and the energy of that photon is equal to the band gap. So this option, which is option E, is correct. LED works only when it is forward biased. Forward biasing means connecting P to higher potential and connecting N to lower potential. So option E is absolutely correct, isn't it? So that basically eliminates answer 3. So we have to work with one option, second option, and the fourth option. Now, another thing that you will note is that option D, it is a very carefully crafted option. It says, if we increase the forward current, then LED intensity increases, light intensity increases. Well, from quantum theory that light intensity depends upon the number of photons. So you may think that if more electrons punch through this depletion region, there will be more recombinations. And if there are more recombinations, then more photons will be emitted. Well, that does happen initially, but once the current reaches a certain value, heating of the LED takes place, which decreases the efficiency of LED, and therefore this recombination, non-radiative recombinations take place. So that drastically decreases the efficiency of LED, and we can't say that the increase of forward current results in continuous increase in LED light intensity. Yeah, initially it does increase, but then it saturates. After a certain point, in fact, the efficiency of LED has been found to decrease. I'm talking about light intensity efficiency. So option D is wrong. If this word continuous would not have been there, it could have been treated as a right option. As I told you, initially as you increase the current, if more electrons go through to the P side, there will be more recombinations and there will be radiative heat transfer, non-radiative. sorry, there will be radiative heat transfer and more number of photons will be emitted then. But if you increase the current beyond a certain limit, heating of the diode takes place, and if diode heats up, the efficiency of electron going from conduction band to valence band decreases, and therefore the number of emitted photons decreases. So D option is not correct. And if D option is not correct, what we can very carefully say is that option 1 is not correct. Option 1 is not correct. As I told you, option E is correct. So obviously 3 can also not be the answer. Now we have between A, C, E and B, E. So let us look at B option. Solar cells are not connected with any external bias. Well, what is solar cell? The principle of solar cell is very similar to photodiode. So let me just explain that here. So in solar cell, we have many diodes placed on the panel. So I'm just drawing one of the diodes. And the region near the depletion layer. So again, I'm drawing the depletion layer. On N side, we have positive immobile charges, and on P side, we have negative, and electric field is like this. This region is known as depletion region. Okay. What happens is that we try to keep this depletion region as large as possible. Reason being, what happens if we want solar cell is one of the mechanisms of converting a light energy into electrical energy. What happens is that we make light incident. Light means photons incident near the depletion region, and if that light has enough energy to take electrons, bounded electrons from valence band to conduction band, then electron hole pair generation happens. Bonds are broken. And if bonds are broken and we have a free electron here, suppose we have this free electron here, this electric field will quickly take that electron to the N side and hole to the P side, thereby creating a current. If we connect externally it to some resistor, we don't need to apply any biasing, any battery. That's what exactly is mentioned here. Option B, solar cells are not connected with any external bias. No battery is needed. In fact, we connect load across solar cells so that we can harvest the photon energy, light energy into electrical energy. So with that, we are able to see that the answer of this question is option 4. B is a correct answer, as I explained, and E is also a correct answer, right? So option C, I told you. Okay, let us discuss about option C. LED is made of lightly doped PN junction. Well, that's not the case. Doping level depends upon the kind of use that you want to put an LED into. LED are made of special materials like gallium arsenide phosphide. But as far as doping is concerned, that depends upon the kind of use you want to put an LED to. So to say that LED is always made of lightly doped PN junction, I don't think that's correct. So let's go to the okay, option A. The junction area of solar cell is made very narrow compared to the photodiode. No, junction area is made large so that many photons fall, and therefore there are many electron hole pair generations, and then this electric field which is present near the depletion region can sweep it across. In fact, in photodiode, we try to keep that depletion region layer transparent, but we don't need to keep it large, because in photodiode is used to measure the relative intensity of the light. We want photodiode to be very sensitive, but as far as solar cell is concerned, the diodes that are used there we want to keep the depletion region as large as possible, so that more photons can be absorbed, and therefore more electron hole pair generation takes place, and this local electric field can sweep it across and therefore create more current. So let us go and to the next question. Again, this question is from the ray optics, and this question is based exclusively on Lensmaker's formula. Let me first quote Lensmaker's formula. Lensmaker's formula is used to find the focal length of the lens. It says 1 by f is equivalent to refractive index of lens material divided by refractive index of surrounding medium, which surrounds it till infinity, minus 1 into 1 by r1 minus 1 by r2. R1 and R2 are the radii of curvature of the two curved surfaces. So it says a plano-convex lens having radius of curvature of the first surface 2 centimeter. So there is a plano-convex lens. First surface means the surface on which the light rays fall first. So suppose this is light rays are like this. So this surface would be the first surface. Its radius of curvature has been given to us as 2 centimeters. And obviously the radius of curvature of the second surface is infinity. So it is So let me find the focal length first of this plane. So it is 1 by f1 is equivalent to refractive index of the lens. Refractive index of the lens unfortunately is not given to us. Divided by medium is 1. 1 by r1. R1 is 2 centimeters minus 1 by infinity. Right. So this will become 1 by f1 is equivalent to mu l minus 1 in by 2. Another plano convex lens with the first surface of radius of curvature 3 centimeter has a focal length f2. So there is another plano convex lens. The radius of curvature of the first surface is 3 centimeter. But that plano convex lens is dipped in a liquid having refractive index 1.2. So both the lenses are made of glass of same refractive index. So refractive index of the glass is also mentioned. Initially felt that it is not mentioned, but that is given. So it is 1.5. So this is 1.5 minus 1, which is 0.5, which is 1 by 4. Now let me write down the focal length of the second lens. So that is lens materials refractive index divided by surrounding refractive index minus 1. The radius of curvature of the first surface there is 3 minus my 1. I think we have to now find the ratio. No, that's a pretty simple stuff, right? So it's 1 by f2 is equivalent to 0.3 divided by 1.2 into 1 by 3. Basically 1 by f2 is equivalent to 1 by 12. And if you take the ratio of f1 is to f2, I think the answer of this question is 1 is to 3. That's pretty simple. Now let us go to the next question. Another question on optics. So this third question on optics in this shift. It says, what is the relative decrease in focal length of lens for an increase in optical power by 0.1 diopter from 2.5 diopter? So first you should know the definition of power. Power of the lens is defined as 1 by f. So what is the relative decrease in the focal length? You can see from this that if power is more, focal length is less. So here power is increasing, so focal length will decrease. So initial focal length minus new focal length divided by initial focal length. And yeah, that's what he's asking. Basically asking 1 minus new focal length divided by initial focal length. What is the initial focal length? Well, initially the power is 2.5 diopter. So initial focal length is 1 by 2.5 meters. And the new focal length is 1 by 2.6. 1 by 2.6 because it's mentioned in the question that optical power is increased by 0.1. So we can just put these values. It is 1 minus 1 by 2.6 would be we can write this as 10 by 26. So this can be written as 5 by 13. 5 by 13. So this can be written as 5 by 13 divided by the original focal length is 5 by 2 by 5. So this is further simplified 1 minus 25 by 26. So it is 1 by 26, or we can write the answer of this question to be 0.04. 0.04. Yeah, so the answer of this question is A part. Let us revisit the calculations. So 2.5 is equal to 1 by f, so f can be written as 1 by 2.5. F dash as 1 by 2.6, which can be written as 10 by 26, 5 by 13. So initially the focal length was 2 by 5 and the new focal length is 5 by 13. So 25 by 26, yeah, approximately it is 0.04. This question is based on little bit of kinematics and de Broglie's wavelength. It says that there is an electron which is initially having a speed of v naught in positive x direction, right? And there's an electric field which is in minus k cap direction. Let us call this as x direction. Let us call this as z direction. Okay, y will be into the plane of the paper. So we have an electric field in downward direction. So if electric field is in downward direction, electron will experience a force in upward direction, and it is going to follow a parabolic path where its speed is going to increase. And if speed increases, a de Broglie's wavelength will decrease, right? And that's what the question is all about. He's asking us to find the de Broglie wavelength of this particle at a time t. Let's first understand this, that electron will experience force opposite to the direction of electric fields. That's in upward direction, and that's going to increase the speed of the electron. And if the speed of the electron increases, de Broglie's wavelength, which is defined as lambda is equivalent to h by p. You can see from here, m is the mass of electron, v is the speed. So if speed increases, de Broglie's wavelength will decrease. So definitely 1 and 2 can't be the answer. So answer has to be between 3 and 4. So let's find that. Let's find the speed at general instant. To find its speed at general instant, we should know its x component of velocity at general instant and y component of velocity. X component of the velocity will stay same because there's no force in the x direction, right? Actually, here we have the z component of velocity. As far as the z component of velocity goes, that we can find very easily from kinematics, like initial z component of velocity plus at, because acceleration is constant, force is constant, field is constant, force is constant, acceleration will be constant. The force acting on the charged particle will be QE. We divide that with the mass, we'll have acceleration. And remember, initially there was no velocity component in z direction, so we finally have this. So an x component will stay there. So at general instant, the speed is going to be under root of v naught square plus e naught by m t whole square. We can take v naught out, right? And so we can write this as h is divided by m v naught under root of 1 plus e square e naught square t square divided by m square v naught square. So the answer of this question is option 3, because h by m v naught, that is the initial de Broglie's wavelength when its speed was v naught. So option 3 clearly seems to match. Let us then go to the next question. This question is based on the definition of angular momentum, and projectile motion concepts are also needed. Let me first define what is angular momentum. Suppose we have this particle which is moving in some random path, and this particle at a certain instant is here at point P, and its position vector is r. Okay, and suppose it is moving with a velocity of v, and the mass of the particle is m. We define a certain quantity called as angular momentum as m into r cross v, where r is the position vector of the particle and v is the velocity of the particle. This can be simplified to, for finding the magnitude, m v r perpendicular. M is the mass, v is the speed, and r perpendicular is the perpendicular distance of line of motion from the point about which you have to calculate angular momentum. Like at this instant when it is at P, this is the line of motion. You just have to extend the velocity vector. And we just need to draw perpendicular on the line of motion from the origin about which you have to find the angular momentum. This distance is r perpendicular. If we multiply this with v and mass, we should have the angular momentum of the particle. As far as the direction goes, we have to go for right hand thumb rule. Direction of angular momentum is an actual vector. It will be perpendicular to the plane containing r and v. So in this case, either angular momentum will be out or in. That we can get from r cross v. In the case that I've just described, angular momentum is into the plane of the paper. So on that note, let us read the question. We have a particle of mass m is projected from origin in a vertical xy plane at an angle of 45. So this is, the particle is projected like this at an angle of 45. It is a projectile motion question, so this is the path that it is going to follow. Okay, this is the point when it is at maximum height. In fact, I believe in this question he is asking us to find the angular momentum of the particle when it has reached the maximum height, means when it is here. At that time velocity will be like this, isn't it? And it will be v cos theta. The initial velocity, which is v naught, it will have two components, which is v naught by root 2 and v naught by root 2. This v naught by root 2, the horizontal component, it will remain unchanged. At the highest point, the vertical component is 0. And at this point, this is the line of motion. And we have to draw perpendicular, as I said, from the point about which we have to calculate angular momentum. In this case, we have to calculate angular momentum from origin. And we need to draw the perpendicular. This is the perpendicular that I am drawing. We should know this length. So m, v, r perpendicular should give us the answer of this question. M, as you know, that's m itself. V, that's v naught by root 2. And r perpendicular in this question is h max. And h max in projectile motion is uy square divided by 2g. Initial y component of velocity square divided by 2g. So uy square is v naught square by 2 divided by 2g, which is v naught square by 4g. So which is V naught square by 4G. The answer of this question, you see, is either option 2 and 3, both are matching magnitude wise, but direction wise we'll have to figure out which one is the correct one. As I told you, to find the direction of angular momentum, we have to do V cross R. R is this vector, a line joining the origin and the point where the particle is currently located. This is R and this is V vector. So R cross V, if you do right hand thumb rule, thumb is pointing into the plane of the paper, and into the plane of the paper is negative z axis. So angular momentum magnitude is mv naught whole cube divided by root 2 4g, and as far as direction is concerned, it is into the plane of the paper. Into the plane of the paper here means negative z axis. So that completes this question. Let us go to the next one. Now this question is based on circular motion. It is based on the topic banking of roads. You see, if we have to negotiate a curve at high speed, friction alone cannot provide the necessary centripetal force. Slipping may happen. So what engineers do is that they bank the road so that when a component of normal reaction can provide the centripetal force. I'm showing you the front view. This is the center of the circle. So basically the car is going to move out of the plane, and means I'm just showing the car somewhere here. The car will go out of the plane and then revolve around this in a circle. I'll try to show it like this. Something like this. So we have to see which forces are providing centripetal force. And they've given us the maximum permissible speed. Means if you increase the speed beyond this, slipping may take place. Let us see what kind of slipping. And the question is saying what is the coefficient of friction. Let me draw the free body diagram. Okay, so this is our normal force. This is the banking angle. Normal force is perpendicular to contact surface. This is gravity. And the only other force here is friction. The question is friction between the tires and the road, is it acting up the incline or down the incline? Well, as I told you, because maximum permissible speed is given, if you increase the speed beyond maximum permissible speed, the tendency of the car to leave the track is going to increase. Therefore, friction must be acting down the incline. Okay. If minimum speed was given, then if you decrease the speed below that, the tendency of the car is to fall down. Okay, in that case, the friction would be acting up. In fact, at the speed v naught, friction will be at its maximum value, which is mu into n. Right. Now, in this question, as you can see, the component of friction and the component of normal is providing the necessary centripetal force. Let us do the analysis of this. Let us resolve the forces. Let us see what are the forces towards the center, because they are going to provide the necessary centripetal force. In fact, you can see that this angle is also theta. So we have n cos theta that will get balanced by mg and the component of friction in the direction of mg, because this car is moving in a horizontal plane. It's not going up, it's not going down. So vertically there should be equilibrium. As far as the radial direction goes, n sine theta plus f cos component, f cos theta, that is providing the centripetal force, which is mv square by r. Please note one thing, that when the speed is v naught, at that time the friction will be at its maximum value, mu into n. If the speed is less than v naught, then friction will be less than its maximum value. The other equation, as I told you, is we have to write in the vertical direction, which is n cos theta is equal to mg plus f sin theta. So if we divide the two equations, we will be able to eliminate n, and we should have the answer of this question. So let me do the calculation of this question. So I'm going to write this equation like this: n cos theta minus mu n sin theta is equivalent to mg. Now let us divide equation 1 and equation 2. So n and n will cancel out. So it will be basically sin theta plus mu cos theta divided by cos theta minus mu sin theta. This is equal to v naught square by rg. Let me go to the next step. I think we can divide by cos theta throughout. So we'll have 1 plus tan theta. Tan theta plus mu divided by 1 minus mu tan theta is equivalent to v naught square by rg. We have to get mu. Okay, so rg tan theta plus mu rg is equivalent to V naught square minus mu V naught square tan theta. So mu I'll take common, we have Rg plus V naught square tan theta is equivalent to V naught square minus Rg tan theta. So answer of this question is V naught square minus Rg tan theta divided by Rg plus V naught square tan theta. Option 4. I hope you understood this question. This was based on banking concept. Let's go to the next one. Now this question is from Bohr's model. In fact, based on Bohr's third postulate, which says that, in fact, as you already know, the second postulate said that electrons can only occupy certain energy levels in which its angular momentum is quantized. Now these are the energy levels that I am drawing, and if electron de-excites from higher energy level to lower energy level, it will emit a photon. The wavelength of that photon or the energy of that photon, according to Bohr's third postulate, is equivalent to the energy difference between these levels. Let me call this EA, EB, EC. EA, EB and EC define the energy of level A, level B and level C. Let's see what's the question. During the transition of electron from A to C, okay, so basically it seems that the question is named this as A, this is B and this is C. So when the electron is making a transition from A to C, as I told you, it is going to emit a photon. The energy of that photon is hc by 2,0,0,0, and this is equal to, as you know from Bohr's third postulate, it is Ea minus Ec, difference in the energy level. And it becomes 6,000 when the electron jumps from B to A. So when electron is jumping from B to A, again photon energy will be emitted, photon will be emitted. The energy of that photon is hc by 6,000. This will be equal to EB minus EC. In this question, he is asking you, if the electron was to de-excite from A to B, what will be the wavelength of the photon emitted? Very easy question. That will be hc by lambda is equivalent to EA minus EB. Very simple question. We just need to substitute the values. In fact, I think we just have to subtract these two equations, and upon subtraction, you will have 3000 as the answer. It's a very simple one. Let us go and move to the next question. This question is based on surface tension and on Young-Laplace equation, which says for fluids which have one interface only, one interface where the phase is changing, pressure on the concave side minus pressure on the convex side, that is equal to 2T by R, where T is the surface tension and R is the radius of curvature of the surface. So what is the question? We have container. There is a air bubble inside the container. Obviously, air bubble will only have one interface, Interface means where the phase is changing. So inside the air bubble there is air, and just outside it there is complete water. It's not like a soap bubble where there are two interfaces where the phase change takes place. In soap bubble, what happens is that there is a one phase change that takes place at this interface. There you can see from this side there is atmosphere, and here there's a bulk liquid, and again at this surface phase change takes place. So there is a bulk liquid above it and there is a gas inside it. In comparison, we have air bubble. In air bubble, phase change only takes place at one interface. Therefore, I am writing Young-Laplace equation as I did there. Pressure on concave side minus pressure on convex side is 2T by R. R is the radius of curvature. So what is he saying? An air bubble of radius, so radius is given, lies at a depth of 20 centimeters. So we know pressure at the top is atmospheric pressure, and it is lying at a depth of 20 centimeters. Means pressure just outside will be P naught plus rho GH, where H is 20 centimeters. And inside, just inside the bubble, will the pressure be same? No. Wherever the interface is curved, the pressure on the concave side and on the convex side are not same. In fact, the pressure on the concave side is more. The pressure inside the bubble is more. In fact, the pressure inside the bubble is 2T by R plus pressure on the convex side, which is P naught plus rho GH. And it has been given the pressure inside the bubble is 2100 greater than the atmospheric pressure. Basically, P minus P naught directly has been given as 2100 is equivalent to 2T by R plus rho GH. So this now just needs to be simplified. I think we have to find the T. Everything else has been given. So it is 2100 minus rho, density of water, that's 10 power 3, G is 10, H is 20 centimeters, 20 into 10 power minus 2, rho GH, multiplied by R by 2, that is equal to T. So it is going to be, I think this and this will cancel out, 10 power minus 2 and 10 power 2. So we'll be left with 2000. So 2100 minus 2000 is 100. So it's 100 into R. R is 0.1 divided by 2. So it is 10 by 2. That is T. I think we need to recheck the calculations here. So 2100 minus density is 10 power 3, G value is 10, and this is 20 centimeters. So it's 20 into 10 power minus 2. So we'll basically be having here, let's cancel out like this, would be 2000. So 2100 minus 2000, that is 100. That's correct. Then we are supposed to multiply it with R. What's R? That's 0.1 centimeters. Okay, 10 power minus 2. Here we have to make the. So this will be 10 by 2, which is 5, which is 5 into 10 power minus 2. So 5 into 10 power minus 2 is option C. It's very easy question based on surface tension. You just need to be aware of whether you have to use 4T by R or 2T by R. That's where the confusion all starts. Because it's an air bubble, only one interface is there. Above that interface, there is complete bulk phase, liquid bulk phase, and below the interface, there is gas. So only one interface, therefore 2T by R. Okay. This formula is only valid for sphere. If the interface is spherical, if it is of any general shape, the formula becomes pressure on concave side minus pressure on convex side is T into 1 by R1 plus R2, where R1 and R2 are the principal radii of curvature. Now this question is from rotational motion, rolling down an inclined surface. Very quickly, I'll explain to you the concept of this question. So this is a fixed incline having an inclination theta. It is rough obviously, and there is some rigid body. This can be a ring or a disc or a sphere or a solid cylinder, and its moment of inertia about center of mass is known. Suppose it is beta mr square. If it is a ring, then moment of inertia about center of mass will be mr square, right? If it is a disk, it is half mr square. Beta will be half. Solid cylinder half, solid sphere 2 by 5. And it is rolling down the incline. We have to find the acceleration of the center of mass. So let me just quickly draw the free body diagram. The only two forces here are friction and gravity, and the two components of the gravity I am marking. This is mg sine theta, this is mg cos theta. Mg cos theta will be balancing the normal from the ground. And there is friction, which, because this body has a tendency to slide down, friction is acting up. Static friction is acting in pure rolling, right? So we will write down the equation that mg sine theta minus F net force is equivalent to mass into acceleration of center of mass. This is what we have to find. The other equation I will write is the torque equation, and we can write torque equation about ICR also, but I'll write it about center of mass. So the only force which is producing torque is friction. Mg sine, mg cos, normal, they're all passing through the center. Only friction is producing a clockwise torque, which is F into R is equivalent to beta mr square into alpha. And there is a no slip condition that A is equivalent to R alpha. If we solve these equations, we get A as G sine theta divided by 1 plus beta. So you just have to substitute the value. So it is G sine theta. Angle of inclination is 45. So sine 45 is 1 by root 2 divided by 1 plus 1 by 2. Which basically is G by root 2 into 3 multiplied by 2. If we multiply by root 2 and root 2, so we can cancel out this 2. The answer of this question is root 2 G by 3. G is outside. I think there is some issue here. There's some error. And the answer of this question should be option A, root 2 G by 3. G is outside. Many people directly remember the standard result, like acceleration is G sine theta divided by 1 plus I center of mass divided by mk square, I think. Or I'm not aware of that result. I have derived it. You can check it out. Now this is another question based on parallel plate capacitor. Very easy question. We should just know the capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor is epsilon naught A by D, where A is the plate area, which you can see in this question has been given as L into B. Epsilon naught L into B. D is the width between the two plates, or the gap, I should say, between the two plates. So he has given us some values, length, breadth, and distance, without, to be very honest, making any changes into the units. Just that L is 3 centimeter, B is 1 centimeter. We are not interested in finding the capacitance. This question wants us to check the effect on capacitance if we change L, B and D. So no need to make any calculations. As such, you can see that capacitance is some epsilon naught units, right? He wants that he wants to increase capacitance by a factor of 10. So he says which option correctly does so. If you check option A, or in option A, it seems like capacitance is increasing by a factor of 30. If you put L equal to 30, B equal to 1 and D equal to 1, you can see that capacitance is increasing by a factor of 30. It becomes some 30 epsilon naught units. So option A can't be the answer, right? So we can check option maybe B. Similarly, you can check C. I think if you look at C carefully, L is 6, B is 5 and D is 3. 6 into 5 is 30. 30 divided by 3 is 10. So you can see that in option C, capacitance does increase by a factor of 10. So where is C? So I think we have to check between options 2 and 3. Let us check E also. In E also, if you can see, L value is 5, B value is 2, D value is 1 micrometer. So 5 into 2 is 10, 10 by 1. So yeah, capacitance here also is increasing by a factor of 10. So C and E seem to be the correct answer. Let us go to the next question. This question is based on Kepler's third law, which says that the time period, the time taken by the satellite to revolve around the planet square, that's directly proportional to the radius of the orbit whole cube. And we can write this direct proportionality as some constant, which you people know does depend upon the mass of the planet and some gravitational constant. You can see that they are giving us two satellite. One is having a radius r and the other one is having a radius of 1.03 r. So they're very close radiuses. In fact, the one satellite having a radius of 1.03 r will have more time period, the time taken to complete one oscillation around Earth as compared to r. But that is slightly more because radius of that second satellite is slightly more. We can use calculus to find the delta t. That's what he's asking. The time period of revolution of second satellite is larger than the first satellite by how much percentage. So we can go for differentiation because there is a very small change in r that is taking place. We have to see corresponding change in t. If r value is changing by a large amount, we can't use calculus. Then we have to go by proper algebra. So I can go for here 2t dt is equivalent to 3k r square dr. I'm going to divide equation 1 and equation 2. So it will be, just let me divide this with t square and this side with k r cube. So we'll have 2 dt by t is equivalent to 3 dr by r. So we have to find dt by t into 100, that is 3 by 2 into dr by r. What's that given as? Dr by r into 100 is given as 0.03. So answer seems to be 4.5%. 9 by 2 into 100 is 4.5%. This is the answer of the question. Now we go to the next question. This question is from alternating current. We just have to find the RMS value. Root means square. So we just have to do the square. We have to square the function. It's a very simple one. We'll square the function. So the square of this function will be IA sine square theta plus IB cos square theta plus 2IA IB sine theta cos theta. The second thing we have to do is we have to now calculate mean. All of you know the mean value, the average value of sine theta cos theta function is 1, isn't it? The average value of sine theta cos theta function is 0. Pardon me. So this term will become 0. In fact, the average value of sine square theta and cos square theta is 1 by 2. So the average of this is going to be IA by 2 plus IB. Okay, there's a square here also, by 2. So we have done squaring, we have completed the mean. Now we just have to find the root, to take the root. The answer of this question is option 4. Let's go to the next one. Okay, this question is from surface tension. This happens to be the second question on surface tension from this shift. What does it say? You know that when we break big drop into smaller droplets, surface area increases. And in order to increase the surface area of the liquid, we have to do the work. The question is saying how much work we have to do. We are going to assume that in this process, density does not change much. In liquids, density doesn't change much in any process anyways. So that keeping volume constant, mass constant, volume constant, we're going to find the relation between the radiuses of the smaller droplets and the larger droplets. And as far as the work goes, how much work we have to do, that is T into delta S. What is T? Surface tension. T, delta S, that's the change in surface area. You know, final surface area for a single drop, it is 4 pi small r square, and there are n such drops. And initial surface area was 4 pi capital R square. So we can take a 4 pi out T into n r square minus capital R square. We must relate small r and capital R. We are going to do that by volume conservation. Density is constant. So initially this is the volume, and finally the volume will be same. It's 4 by 3 pi small r cube into n. So this will cancel out, and we will have small r equal to capital R divided by n power 1 by 3. So I write that here, it is 4 pi T into n r square into n power minus 2 by 3 minus r square. So we can take 4 pi T r square out. This will be n power 1 by 3 minus 1. This is the work that we have to do. What is the question of saying? The work done required to break the same drop into 64 droplets is, okay, so he has given us, I think, work done to break a big drop into 27. So let's call that W, and that is going to be 4 pi T r square into 27 whole power 1 by 3 minus 1. And we have to find the work done to break the drop into 64 droplets. So that's 4 pi T capital R square into 64 whole power 1 by 3 minus 1. Pretty simple one. So W dash by W is equivalent to 64 whole power 1 by 3 is 4, 4 minus 1 is 3. So that's 3 divided by 27 whole power 1 by 3 is 3, 3 minus 1 is 2. So W dash is 3 by 2 into W. W is 10, so that's 15. Let's go to the next one. This is a very simple question based on significant figures. You know the rule. In division, in multiplication, the rule is the answer should have as many significant figures as the one with the least significant figure. If you see, in the original question, we have three numbers: 32.3, 112.5, and 27.4. 32.3 has three significant figures, 1125 has four significant figures, 27.4 has three significant figures. Our answer should only have three significant figures. Look at the options. In the very first option, we have five significant figures. In the second option, we have three. In the third option, we have six. And in the fourth option, we have seven. So the answer of this question is straight away 2. We don't need to do any calculation. And we need to pick up such a number where the number of significant figures is 3. Remember that the terminal 0 is not significant. It's only after decimal that they become significant, right? So if I write, for example, 133.0, it's here that we have four significant figures. The terminal 0 does become significant. But in case there is no decimal, then the 0, the terminal 0, that is not significant. Now this question is from experimental physics. It's based on screw gauge, and let us see what's the question all about. It says the least count of a screw gauge. Okay, how to find the least count of a screw gauge? Well, the basic formula, least count of the screw gauge is pitch divided by the number of divisions. What is pitch? Pitch is the length covered by the ratchet when we give one complete rotation to it. And n is the number of divisions on the circular scale. Okay, so let us see what the question is all about. It's a very simple, straightforward question. It says it has given least count of a certain screw gauge to be 0.01 millimeter. And that screw gauge has some pitch and some number of divisions. Now what is he doing? If the pitch is increased by 75%, means if initially the pitch was P, now it is P plus 0.75 P. It is 1.75 P. And what has he done for the number of divisions? That have been reduced to 50%, means now the number of divisions are only 0.5 times n. So I believe the question is asking us to find the new least count. That's pretty simple. Remember, the old least count was 0.01. 1.75 divided by 0.5 is 3 by 2. We can do the calculation. That's 175 divided by 50. Yeah, it is. We can see that that is 7 by 5. And I think we have to go for calculation, proper calculation. So 3.5. Yeah, it's 3.5. It is 3.5. So 3.5 into 0.01 millimeter. So that is 35 into 10 power minus 3 millimeters. That is the answer of the question, 35 into 10 power minus 3 millimeters. Now this is the other question. It says the temperature of 1 mole of ideal gas is increased by 50 degree at constant pressure. This is an isobaric process. In isobaric process, if you have to calculate heat supplied, that's given by NCP delta T. And if you have to find change in internal energy, well, internal energy is a state function regardless of the path, regardless of the process. Change in internal energy is same. We just have to find the ratio of Q by delta U. See how easy it is. That's Cp by Cv. Cp, well, it is a monoatomic gas, so Cp will be 5 by 2 R, and Cv for monoatomic gas is 3 by 2 R. So the answer of this question is 5 by 3, and 5 by 3 has been equated to x by 9. The answer of the question is 15. A very simple question, x is 15. This is the other question. I think this question is from current electricity. Very simple question. A wire of resistance 9 ohms is bent in the form of equilateral triangle. So each side will have a resistance of 3. In equilateral triangle, all sides are of same length. Length is proportional to resistance. So this will have a resistance of 3 ohm, 3 ohm, 3 ohm. What is he asking? Asking us to find the equivalent resistance between two vertices. These 2, 3, they are in series. It will be 6. And 6 and 3 are in parallel. So it is 6 into 3 divided by 6 plus 3. That is 2 ohms. Now we have this question. This question will most possibly go as a bonus, because unfortunately in this question they have not given the distance of charge from the surface. We have to find flux. This question is from Gauss's law, electrostatics. We have to find the flux through the square face. There is a very famous result that if we have a square face of some side length A, and from the center, if the charge is at a height of A by 2, which basically means that if we complete this square on all sides, this charge which is at a height of A by 2, it will be at the center of that enclosed cube. And we know by Gauss's law, the flux through the cube will be Q by epsilon naught, and because it is at the center and because of symmetry, all flux through all the faces will be 1 by 6th of Q by epsilon naught. So flux through this base, that is going to be Q by 6 epsilon naught. And what I have done is that I have divided this base into 8 equal parts. And if you look at this question, if we assume that Q is at a distance of A by 2, the question is asking us to find the flux through this surface. Again here, because of symmetry, through each part, through each right isosceles triangle, flux will be Q by 6 epsilon naught divided by 8. And in our case, there you can see we have 8 such isosceles right angle triangles. So flux through 1, 2, 3, 4, 5. Oh, sorry, we have 5 only. So 8 is the overall. So through 5, it will be 5 into Q by 6 epsilon naught multiplied by 8. Q by 6 epsilon naught is the flux through the entire square face. And I divided that square face into 8 right isosceles triangles. And this charge is symmetric with respect to all of them. So through all the right isosceles triangles, flux will be same. And by unitary method we can find, if through the 8 flux is Q by 6 epsilon naught, so through one of them it will be Q by 6 epsilon naught multiplied by 8. And we have 5 such isosceles triangles, and the flux is going to be 5 into Q by 6 epsilon naught by 8. So answer of this question is 48. 48 is the answer of this question. If we assume, as I told you, that Q is at a distance of A by 2. If it is not at a distance of A by 2, then we have to use some solid angle that is out of the scope of our syllabus. Solid angle subtended by a square at any point on its axis. Anyways, this question is from Biot-Savart's law. So in this question, basically we have a square loop. We have to find the magnetic field at the center, and it's carrying a current like this. Current is given. The length of the square loop is also given. So we have to use principle of superposition very simply. We'll find magnetic field due to one conductor AB. If you see carefully, all the conductors contribute magnetic field in the same direction at point O. Use right hand thumb rule, keep your thumb, right hand thumb in the direction of the current and you curl it, you will see that at point O, magnetic field created by A is into the plane, BC also, because of BC also into the plane, CD also into the plane, AD also into the plane. So if we find magnetic field due to AB part at O, we just have to multiply by 4. And magnetic field due to finite conductor is a very standard result, mu naught I by 4 pi D into sine alpha plus sine beta. These alpha and beta are the angles subtended by the ends of the finite conductor with the perpendicular distance. Remember, the perpendicular distance is D, which in this question is 1 by 2 root 2. So 1 by root 2 is the total length, and we basically here is this entire distance is 2D. So we have mu naught I is 5 divided by 4 pi D is 1 by 2 root 2. Okay, and this is multiplied with sine alpha and beta are 45 45, so that's 1 by root 2 plus 1 by root 2, and this entire thing we are supposed to multiply by 4, because there are 4 such conductors contributing equal magnetic field at O and in the same direction. So this should be the answer of the question. We can easily figure out what is the answer. For now, what we can do is mu naught 5 divided by 4 pi into 1 by 2 root 2 multiplied by 2 by root 2 into 4. So this 4 and this 4 is cancel out. This 2 will multiply to become 4. So it is 4 mu naught by 5, and I think this will also cancel out. I think this answer of this question will be, we can go for proper calculation. Just a second. Let me do the proper calculation. So it is 2 root 2 mu naught 5 divided by 4 pi into 4 into 2 by root 2. Root 2 will cancel out. Here this and this will also cancel out. So it is mu naught into 20 by pi. So mu naught itself is 4 pi into 10 power minus 7 into 20 by pi. Pi and pi will cancel out. 8 into 10 power minus 6 seems to be the answer. The answer of this question is 8 into 10 power minus 6. 8 is the answer. And with that, we complete this discussion of the first shift 24th evening. The paper was fairly simple, and I hope all of you have done very well.